Yes. Welcome back. We are still on the section of electrochemistry. The electrochemistry. Electrochemistry. Chemical. In this section, we have got electrochemical cells. Don't forget, we said we have got a galvanic cell. That's what we dealt with previously, and electrolytic cell. What is the difference between the two cells? If you want to master these two, remember both of them are dealing with the redox reaction. But in a galvanic cell, which some they call it a voltaic cell. Voltaic cell, it's normally producing voltage. The first difference is energy conversion. So galvanic cell convert chemical energy to electrical energy. Whereas in electrolytic cell, we are converting electrical energy to chemical energy, and that we forge chemical reaction using electricity. Now, what you should know as a result of this production of electrical energy in galvanic cell, the cell itself is said to be exothermic. Exothermic, meaning that energy is released there. Whereas in this electrolytic cell, then is endothermic. We require energy for the cell to cell reaction to take place. Now, the other difference between the two is that in the galvanic cell, we have got a salt bridge, which lead to the type of reaction being classified as indirect electron transfer, whereas this one there's no salt bridge. And as a result, if you draw it, you will see that the structure of a galvanic cell will be having this format. We might be having two electrodes, which are solid materials, and with a voltmeter connecting the wires in the external circuit, and in the internal circuit we have got our salt bridge. We have got electrolytes in each half cell. Whereas in the electrolytic cell, you'll find that now the whole reaction takes place in one beaker, where now if there are two electrodes, the two electrodes will be found in the same beaker. And then we have electrical energy. Don't forget, if you are doing chemistry, that in electric circuit we learned that the long one is positive and the short one is negative. Therefore, the electrode that is connected to the positive terminal of the battery will be positively charged, and this one will be negatively charged. So that is in a nutshell the difference between the two cells. And then if we still remember, we know that in the galvanic cell, if the negative electrode, there's a positive electrode. The positive electrode is the cathode, and the negative electrode is the anode. But in an electrolytic cell, the positive electrode is the anode, the negative electrode is the cathode. But when coming to reactions, don't forget that nothing changed at the anode. That's where oxidation takes place. Oxidation is still taking place at the anode. And then at the cathode, again, reduction is taking place. Therefore, in both cases, this is the same, that when you are at the anode of the cell, the oxidation will be taking place there, and at the cathode, reduction will be taking place there. The last difference before we move over is that the electrolytic cell is spontaneous. The reaction there can take place without adding any energy. Spontaneous, it can take place on its own, whereas in an electrolytic cell, the reaction is non-spontaneous. Until you supply energy to the cell, no reaction will take place. So in this case is non-spontaneous. This side, if they can ask you why, is because the EMF of the cell is positive. This side, though we are not going to calculate it, the EMF of the cell will be negative. It's not calculated in this case. We only calculate the EMF in the galvanic cell. All calculations, you must get positive in this case. A EMF, it means that if your calculation in the galvanic cell gives you a negative EMF, know that that cell, that connection that you have made in the cell, it's non-spontaneous. Thanks, and let's pause and then continue later.